Hello and welcome back to the GCSE help videos for maths. Today we'll be going over sequences, in particular arithmetic sequences, as you can see here. So the first things we need to know is these different terms. So n is just the number of terms in a series. A will be your first term, and D will be your common difference. An arithmetic sequence has this common difference, so a number will keep increasing by the same amount over and over and over again. So this formula here that we have, a plus n minus 1 times d, will give us any number of this series as long as we know the initial first term as well as the common difference. So in this first example, we know that the first term is a, so we can say that a equals 6. And what is the difference between 6 and 11? That will give us our common difference, and this will keep on repeating. So our common difference will be 5. Now, if we wanted to find x in this situation, all you would have to do is really add 5. But if we wanted to use the formula, which we will need to solve for bigger numbers, we're going to say a is 6, so 6 plus n. What is n? What term are we trying to find? We're trying to find the fifth term in the sequence. So we're going to do a plus 5 minus 1 times d, which is 5. So it would be 6 plus 4 times 5, which equals to 26. Now, to apply this further, in our next example, we can apply this same formula that we had above to solve this. So the 6th and the 21st term of an arithmetic sequence are 13 and 43 respectively. Now, if we use the formula, we'll see that 13, if we plug in our numbers, 13, which is the 6th term, would equal a, which we don't know and we're trying to find, plus n minus 1, so the 6th term, so 6 minus 1, so 5 times d. What else do we know? That the 21st term, which is 43, is equal to a plus 21 minus 1 times d, so 20d. Now, what does this resemble? This resembles a simultaneous equation. Very simple. All we have to do is make a the subject here. So a will be 13 minus 5d. We plug it in. 43 equals a. So we're going to substitute 13 minus 5d plus 20d. So what are we going to end up with? We're going to move this to this side. We're going to add both of these two up. So we're going to get 43 minus 13, 30 is equal to 15d. What does that give us? That gives us d equals 2, and we divide 30 by 15. Now we can put this back into our equation. 13 equals a plus 5 times 2. 13 equals a plus 10. And a will ultimately equal 3. So these will be our two answers. Now we move on to the harder topic of arithmetic series, and this is the sum of arithmetic sequences. The formula is a little bit different. They will still give you both of these formulas on your exam paper, so don't worry, you don't need to remember them. It would be n over 2 times 2a plus n to the minus 1d. It's always like this. If you want to find the sum of a bunch of terms in the same arithmetic sequence. So if we do this one from the start, so it wants us to find the first 20 terms. So we're going to do 20 over 2 times 2a, so a is 6, so 12 plus 20 minus 1, so 19 times d. So we have d here, and what is d? D is the difference between there, times 7, and all of that will equal 10 times 12 plus 19 times 7, which is 143. 143 plus 12, you can obviously do this in your calculator if you wanted to. 155 times 10 would be 1,550. And this is the sum of all of the 20 terms in the series. Now, moving on to our application question for this, we are gonna have question B. So what is the minimum number of terms required for the sum of the first n terms to exceed 4,000? Now, don't be scared by this question. All we have to do is use the same formula as before, the sum formula, and make it greater than 4,000. So what do we have? N over 2, so we don't know n. N is what we're trying to find. We have A and we have D. Remember, A is 6, is from the same question, and D is 7. So what have we got to do? 2A, 12. 2 times 6, 12. Plus n minus 1. We don't know n minus 1 times 7. We can simplify this whole thing out. What can we simplify it to? Well, we can times these two to factorize out the brackets. And we'll get 12 plus 7n minus 7. And so 7n plus 5, because we're doing 12 minus 7, obviously. So now we have 4,000 is less than n over 2 of 7n plus 5. What we're going to simply do is times it by 2. So 8,000 less than n times 7n plus 5. Expand out the brackets. And this will give us a quadratic. Remember, pull everything to one side in the quadratic. If you need a reminder, you can always go on the first video which I made of how to solve quadratic sequences, quadratic equations, anything of that sort. So 7n squared plus 5n minus 8,000, we'll bring it all across, is greater than 0. Now, for these sorts of questions, you can use your Casio calculator. Casio Classways, we're going to go down on the menu. We're going to go into equation, polynomial, degree of 2, because it's a squared, it's a quadratic, and we're going to put in 7, 5, and minus 8,000. And this will give us an answer of n is greater than 33.45, and n is also greater than negative 34.165. Now, we don't need this because this is a negative. It can't be a negative term because it's an arithmetic sequence. The terms go from 1 upwards. So we're going to take this answer. Now, this isn't really the full answer because it can't be, the term needs to be a whole number, a whole positive number. So we're going to round up because 33 wouldn't make the number exceed 4,000. So we're going to need to round it up. So n would be equal to 34. Thank you so much for watching this new maths video. Hope you enjoyed, and remember to subscribe.